Okay, so looking at number 9, we're asking to solve for x. We have this multi-step equation. So with our multi-step equations, we have a set of steps that we have to follow in order to come up with the value of x that's going to make that equation a true statement. And the first thing I'm going to do there is I'm going to use the distributive property to get rid of parentheses. So I'm going to multiply my 3, that outer number, times everything on the inside, and that's going to give me 3x minus 6 equals 5x minus 26. So we get rid of our parentheses first. The next thing we would do is we'd look on the left-hand side and say, can I combine any terms there? No, I can't. Can I combine any terms on the right-hand side of that equal sign? You can't do that either. So distribute first, look to combine like terms on each side would be my second step. After I've done that, I want to get all my variable terms together on one side. I'm going to subtract 3x from both sides. And that's going to give me negative 6 equals 2x minus 26. Now, your teacher may have told you always get your variables to the left-hand side. That's not wrong. It doesn't matter if I move my variables over here or if I move my variables over here. I usually do the side that has the larger variable value, 5 being bigger than 3, because that's going to ensure that my variable is positive, but that's a preference. You could have just as easily made this side of the equal sign your variable side by subtracting 5x. You'd get the same thing that way. So I've got my variables on one side. Notice each step of the way, I'm trying to make this complex equation a little bit easier. I've taken this down and made it a two-step equation, which we've been solving for a couple of years now. So how do I solve a two-step equation? I get my variable term by itself by undoing addition subtraction. To get rid of minus 26, I add 26 to both sides. And I get negative 6 plus 26, positive 20, is equal to 2x. And then last but not least, notice again, every step's a little bit simpler. I've got it down to that simple one-step equation. I divide both sides by 2. I see x equals 10. Now, keeping in mind, we should be able to use that value and plug in to make sure that we have the true statement. So as I check my work, if I plug in 10 for x, I'm seeing that 3 times 10 minus 2 should give me the same value as 5 times 10 minus 26. Let's see if that's true. 10 minus 2 is 8. 3 times 8 is 24. If I've done it correctly, this side should equal 24 as well. 5 times 10 is 50. 50 minus 26 is also 24. When I plug in that value of 10 for each of those, notice I get a true statement that 24 equals 24. I feel 100% certain about that problem now. If you're not coming up with the same answer, you're drawing a blank right there, keep in mind one of these 4 problems, in this case letter A, one of those 4 answers is correct. You could plug that value in. Okay, that didn't give you. So you could use process of elimination. That's not our go-to. If I was doing that, I would do that last on a standardized test or quiz. But if one of those 4 answers has to be true and you don't remember how to solve that correctly, you could always start plugging that value in for x and see does it get a true statement. No, maybe that value would give a true statement. So you do have that option if it comes to a last resort, if it's a standardized test or quiz.